Welcome to PCB Tech Labs. In this video I will demonstrate two simple fade-in fade-out circuits using only discrete components. The operation for both circuits is the same. This large capacitor is charged and discharged through different resistors. It's connected to the base of a transistor, and the output of this transistor is analog to the voltage across the capacitor. This is the first circuit. This resistor controls the charging time. When I press the button, the current flows within this resistor and charges the capacitor. The LEDs fade in slowly. The bigger this resistor is, the slower the LEDs will fade in. When I release the button, the capacitor discharges slowly through this resistor. The LEDs now fade out as well. The bigger this resistor is, the slower the LEDs will fade out. This circuit has two major disadvantages. First, these two resistors perform a voltage divider that is always part of the charging procedure. This makes it difficult to set different fade-in and fade-out times because the values of these resistors must be very carefully selected. Wrong values may result in poor LED brightness. The most important drawback, though, is the fade-in delay. Because this charging resistor is always connected in parallel with the capacitor will be completely discharged if no power is applied for some time. When power is applied again, there will be a delay until the LEDs start to fade in. This LED will turn on immediately when power is applied. Notice that the LEDs do not start to fade in immediately, but there is a big delay. All above problems are solved with this second circuit. I have introduced a PNP discharging transistor and a potentiometer. The PNP transistor is used to separate the discharging resistor from the charging time. This way, one resistor is used to set the charging time and one the discharging time, making it much easier to set custom fade-in and fade-out times. As far as the initial fade-in delay is concerned, this potentiometer gives a solution. It provides a constant voltage to the capacitor and does not allow it to discharge completely. These two diodes are placed to prevent this potentiometer to take part of the charging and discharging characteristics. So now, the LEDs will start to fade in immediately when power is applied. Another use of this potentiometer is to set a low brightness standby function. I can set it in a way that the LEDs are barely on. When I press the button, they will fade into full brightness. And when I release the button, they will return to the standby brightness. Finally, a power transistor can be easily interfaced to both circuits shown before and increase the current output. The fade-in and fade-out times are of course not affected, no matter how many LEDs are controlled. The schematics and a full documentation can be found in my website, that is www.pcbheaven.com. Thank you for watching this video and don't forget to visit my website for more interesting circuits.